Okay, I'll give you a little progress report here. It took me not quite as long as I thought it would to remove the transistors by way of the wire brush, the brass bristle brush. It made a mess, but not too bad. I kept the soldering gun on it, and then I immediately took it off, immediately rubbed it with the brush, and I got them off. It's not looking too nice in there, but I don't think I ruined it. Now there's no longer an base to collector short. Everything's good on the board. I'm checking these resistors here. This is a 0.05 ohm, but I'm reading a half an ohm, not 0.05. These resistors go to the emitter. There is a base to collector short, as I figured it would be. This is the first transistor I took out. That's why there's no heatsink compound on it, because I cleaned it off. These are the ones that I pulled out. One of them is shorted from base to collector, and I believe the other one is too. It's either that or open. This one's open. So, as I figured, that at least one or more of the transistors were bad, so my suspicions were correct. Now, the point I was trying to get across to John Speeder was that you have to get the transistors out before this board will come out, because the board is sandwiched in between the heatsink and the transistor connections. Your transistors sit on top of the heatsink right here. Leads go down through the board and soldered on the back of the board. Okay? So with the transistors in there, even though you take out the bolts, you're not going to remove this board unless you unsolder them, which I did. So that is the point I was trying to get across to John. John, you listening? All right, so we got that covered. With my blue ESR meter, all these capacitors, 6,800 microfarads, are all in parallel. And they're in parallel to these two rails here, your negative, which is on your left side because you're looking at it this way with the transistors on the left, and the positive being on the right. You can see where the plus lead here is connected. All right, so you take 6,800 microfarads times 6 at 25 volts. So we're on the 25 volt. You should be reading is 10,000 microfarads, okay? So the chart only goes up to 10,000 microfarads. So here it is reading 0.05. Okay, on the ESR. Alright, so we zero out the ESR meter. We got the lead shorted over here. I don't know if you can see that or not. Okay, we zero it out. We got one lead on the positive rail, and I'm going to try to get a clip lead on the negative rail, but these leads are kind of short. The clip leads are small. Okay, there it is. 0.01. That's the ESR of 6,800 microfarad, 6 of them in parallel. So I would say the ESR is very good. but the leads is not making good contact. Let me put a larger clip lead on the negative and see if I can, it's actually longer, but let's just see if I can get a better reading. 06. All right, let's short these out again. All right, we got to zero that meter again, okay. 0.05. 0.05 ohms. So that would seem to indicate, if my figuring is correct, because the chart don't go up that high, it only goes up to 10,000 microfarads. So I would say that the ESR is very good on those 6 capacitors, and there's no bulging on any of the caps. No leaking, nothing else. Now if you look here, you got R26A and R26. On the other side of this one is 1/10 of an ohm. That is not on the schematic. On this one, I really don't know. Let me look and just give you the number. These are both 0.1 ohm, 1/10 of an ohm. R26 and R26A. There is no R26A on the schematic, but there is a 10 watt listing here. These are 5 watt resistors here. These resistors are 5 watt. This is 5 watt, so they probably took 2 of these and put them in series. I haven't traced out the circuit yet. So to make 10 watts, so here it is here. Here's R26. Now, there's 3 transistors here. So as far as I know, these 3 transistors here are the 3 that's on this board. However, this is R27 and this is R30. Remember now, we're still working on one board. We did not take out the other board. So R27 is right here. However, R30 is way down here on the next board, which I did not pull out yet, which contains 3 more transistors. That board is still in place. I have not removed it. So it's kind of baffling about that. And why those resistors are on that board. When R30 is plainly on this board. So theoretically, R30 should be up here, along with R26. All right, but it's not. It's down here. So it's very puzzling. Thought maybe the schematic isn't exactly right, or there might have been a change on the schematic, or even a mistake. But regardless, I got these out, and at this time, that's as far as I'm going with this. I just wanted to give you an update, let you know that I did get it out, and after having some time thinking about it and so forth. And brushing off the solder, which I think worked out really well. I added a little fresh solder to some of the joints. I labeled where my thumb is over here on the left, black magic marker. So I'll make sure that I put the wire back, the negative wire with the small outlet eyelet goes in that corner there. All my hardware is in here, in my metformin bottle. And the pointed heatsink screws are in here, and the case screws are in the magnetic tray. If I don't label these things like this and put them in proper places, and I take something apart, you can bet that will have the screws in the wrong place, or I'll be losing them. So when you get up in years, you must label everything. When I talked to Mike about this Saturday night, he recommended that I should really bond the negative to the case, even though I didn't get a reading. And it would be better that way, so we will do that. Even though, because of the coating that's on the heatsink here, and the collectors of all the transistors were not on mica wafers, insulators. They were just with heatsink compound directly to this. Because of this coating here, it seemed to protect, in other words, insulate, I should say, the collector from the heatsink. And there is no Teflon sleeves in these holes for the screws. In other words, they go right in. It just happens to be that they're not, I took an ohm meter reading and I got infinite readings, so there was no ground. It really probably does not matter that the case is grounded or not, but we'll probably do that anyways. And I'm going to leave this side in until I get the transistors from George. We'll replace these here, and I'm going to measure these resistors off camera. I measured this one, and with the resistors out, let me get you a close-up of the circuit here. With the resistors out, not the resistors, with the transistors out, each resistor goes to the emitter. So with that out, I should get an accurate reading on the resistor. However, this particular resistor has two wires coming out which go to the 2N5404 diodes up here. So the two positive ends of the diodes go down through here. Okay, so each time I pull out a transistor, the resistor goes only to the emitter of each transistor. So in theory, your resistor is out of circuit, okay? The same way with this one. Now, I haven't measured these yet, and I will. It's a good time to do it now that I got the board separated from the heatsink. It makes it a lot easier to work on. But I'm very puzzled about R30 not being here where these transistors were, and shows R30 right here. But R30 is, sorry about the magnifier, but I can't see without one. Here's R30 right here, okay? But that's on the other board. That's not on this board, and this is the board I just took the transistors out. not this one. Alright, so I guess I'll put this video together and upload it. I just want you to know that I'm going through it, and sometimes, it's better to talk to somebody and get some ideas, and I figured why not use the brush? Mike gave me an idea to just take and use a flat blade screwdriver and just scrape off as much as you can, and, pry the transistor out gently from that. And then after all three transistors were removed, this board came off the heatsink very, very easily. So it was held on to the heatsink, the board that is, by way of the base and emitter soldered connections, because it held the board up onto the heatsink. So, alright, so we knew that. We knew that we could not remove it any other way. I got to unplug this soldering gun here. We don't need it for any more for tonight. We put our leads away. We'll end the video. Yes, I know it's an electronic video, but there are some of you that are following on this. So there is a light at the end of the tunnel. And what I started to say before, I do get sidetracked, and that's why my videos are long-winded. But again, I'm not as long-winded as Doug, so he'll always have the crown. Mike assured me that I would not have any problems as long as there's no shorts here. Nothing is shorter than the output. That I can just put in all 6, 3 on each board of the 2N3771s when I get them, instead of just going ahead and temporarily either trying one or trying a 2N3055 with a very light load on this, which is what I was going to do. So just put all 6 in, make sure the heatsink compound is in, and make sure there's no shorts. We know now that the base to collector short was due to 2 bad transistors, base to collector short, and of course this one didn't have a base to collector short, but it was open. So I figured that, and this has a base to collector short on this board also, so we know there are bad transistors here. So I'm hoping that when I put all 6 in there, that they don't short out again. And if they do, well, at that point, this will be going to the spring auction. No ifs, ands, or buts. And I get all the transistors in, and they go powy, kapow, boom, or puff, or whatever you want to, whatever sound effect it'll make. And if I start smelling smoke, or put my own meter on here and find out that I've got shorts again, well, then I will give up on this, and it will go to the ham auction, and maybe I can get a few dollars for it. I hope that's not the case. Okay, that's the story there. So we are going to end this video. There'll be no more on this video until the transistors come, at which time I will put in the transistors in this board, put this back in, of course put this back together, use the heatsink compound, do this board off camera. When it's all together, I will, before firing it up, I will check for shorts, plug it in, try it out, and hope it works. If it don't work, but does not short out, this is very hard to get at in here, I will probably bring this board to Mike. Now, I don't know if he would work on it. He does surface mount work. He has done it. He's worked on professional wireless microphones for recording studios and stuff, and that was his line of work. So he's done a lot of surface mount devices, and he's still got excellent eyesight, and I think he's got the equipment for it. So, I mean, if it's like this I see here, it would be beyond me or anyone else I know of to repair that. But if I don't blow the 6 transistors out, or short them or whatever, and it still don't work, and if it's in this board, other than testing diodes, which I'll test again, I did test them. Mike did make one mention though. He told me to check the voltage of that Zener diode, and I told him that there is no Zener voltage there. And he said, well, you can probably look it up and find it and see what the Zener voltage is, and make sure you have that Zener voltage on that diode. That might be a little hairy for me to work on because it's way too small. I'm going to read this to you. It looks like a LM, like Larry Mary, 514CN or 614CN. Right there. But I'm not going to go that far right now. I want to concentrate on the pass transistors first. Where the Zener is, I have no idea. It's just too small for me to work on. If the Zener is one of them components that are hugging the board, I'm not going to be able to, I'll ruin it trying to get a probe on it. And I can't work with stuff like this. It's just too small. Way too small for me to work on. So I could probably give Mike this board and he would probably be able to figure it out. But it's going to be one of these things where he'd have to troubleshoot the board without the power supply, and that might be very difficult to do. Because I'm not sure how you're supposed to check the Zener voltage unless it's hooked up to the rest of the power supply. But I could be wrong. I have been known to be wrong 99% of the time. That's it. I'm heading into the house. I got to go out to Subway and pick up grinders. Monday night is grinder night, or subs, whatever you want to call it. So I'm going to take a run down there. I'll probably get spicy Italian. They still have the $4.99 foot-long subs. So that concludes this video for tonight. If you're very unlucky, you may get to see it. Or if you're looking forward to it, then I would say you are very lucky to get another video 2 in 1 day. But don't hold your breath. You could turn blue waiting.